Solid sodium and chlorine gas can react together to make sodium chloride. They don't recommend that you do it this way. It's a lot easier just to go buy it. Sodium's a metal. It's shiny. It can be cut with a butter knife, so it's relatively soft. Now, you can't store it in water, though, because it reacts very violently with water. It produces hydrogen gas, it produces a lot of heat, and quite often, so much heat is produced in a short period of time that it ignites the hydrogen gas. It also produces sodium hydroxide. The reason why the Petri dish has a purplish color to it, pink color to it, is I put phenolphthalein in there. And phenolphthalein is an indicator which detects the presence of a base, and sodium hydroxide is a base. Chlorine gas can be used as a disinfectant. It's used in quite a few industrial processes, but it's pretty dangerous. This is a picture of a 1916 poison gas attack of Germany on Russian troops. When you inhale it, it reacts with water in your tissues to form hydrochloric acid. Fritz Haber and some scientists helped deliver methods to generate and release chlorine gas on the battlefield. It was very effective, at least initially. Of course, it is very dependent upon which way the wind's blowing, which is dangerous. They learned how to counteract it relatively quickly by using gas masks that had, say, activated charcoal in them. And just a comment, mustard gas is not chlorine gas. Mustard gases have sulfur in them. Okay, so you take solid sodium, which reacts violently with water, and react it with chlorine gas, which kills you, and then you make sodium chloride solid. Sodium chloride is used as a preservative. We need sodium and chloride ions in the body. So the point of doing this part is simply to show you that the properties of the elements are not the same when you put them into compounds. So yeah, sodium is explosive in water, but that's not the same thing as sodium ion in sodium chloride. The goal is not to learn how to make these compounds. The goal is to learn how to identify them and how to name them. So we're starting off with ions, so then you can use these ideas to name and write the chemical formula for ionic compounds. Now right now, we're focused on just determining the charges on monatomic ions in main group elements. Monatomic means monoatomic, and the main group, that's columns 1A and 2A, and then 3A through 8A. Ions are composed of one or more atoms that collectively have a net charge on them, either a positive charge or a negative charge. So we have cations and we have anions. Let's start with the cations. Metals are expected to form cations. Now, sodium has a positive charge on it. And I've written that three different ways. So the charge is superscripted to the right. And you see I've written it as a plus, a 1 plus, and a plus 1. Personally, I don't care which of those three that my students use. But the first way is the IUPAC recommended way of writing an ion with a 1 plus charge on it. So if you're using some sort of online homework system, you need to check that out because it may only accept that first way. Well, that's sodium ion. What about other ions? Well, as it turns out, we can use the periodic table to help us. If you make an ion out of something that's in group 1A or group 1, depending upon which method you're using to number your columns, it has a positive charge on it. Similar for these other two groups. Group 2A, 2 plus. Group 3A, 3 plus. And I've made a distinction down there. For 3A, it's the metals. And that's because you've got boron at the top of 3A, and it's not a metal, and it's not expected to form a cation. Now, at this point, I'm not discussing why the charges are what they are. In other words, why is group 1A 1 plus for the charge? Why is group 2A 2 plus? And why is group 3A 3 plus? I'm going to do something at the end to help you distinguish between the number of protons and electrons, but as to why, that's not part of this discussion. Now the anions. Chlorine has a negative charge on it. Similar thing as before. I've got 3 different ways of writing the charge. Minus, 1 minus, minus 1. And again, personally, I really don't care which of those 3 you write. But the first way, Cl minus, that's the IUPAC recommended way, and watch your online homework systems. You also need to follow the method that your instructor says to use also, in addition to that. Chlorine is in 7A, or in column 17. So if you make an ion out of something in group 7A, it has a negative charge on it. Group 6A, 2 minus. Group 5A, 3 minus. And call attention to groups 5A and 6A, and it's the nonmetals. So remember, metals form cations, nonmetals form anions. Now a couple of columns I've left out. I left out column 8A, the noble gases, on purpose because they tend not to form ions, so ignore them right now. And I left out column 4A. The books will sometimes talk about anions for carbon and silicon. The thing is, they tend not to form anions. More often, they form molecules. So we'll leave them out of here. And there are some things with tin and lead, but we'll deal with that at a later time. Now, as to where the charge comes from, not the reason for it, just where the charge comes from. Let's look at the number of protons and electrons. Well, sodium has 11 protons. Well, since sodium ion has a positive charge, it must have 12 protons, right? No, it has 11 protons. Sodium has 11 protons, whether it's an atom or an ion. Well, sodium, the atom, has 11 electrons. Since it's neutral, the number of protons and electrons must equal. So sodium ion, that must have 12 electrons because we've got a plus, so 1 more electron. No, it has 10 electrons. If something has a positive charge on it, it has fewer electrons than protons. That's the way to think about it. Do not adjust the number of protons, adjust the number of electrons. Because if you change the number of protons, you change the element. If you change the number of electrons, what you're doing is you're changing the charge. So chlorine, whether it's an atom or an ion, it has 17 protons. The atom has 17 electrons, and then the ion has one more electron than protons. That's why it has a negative charge on it. So be careful when you make your study notes, because a lot of people will write those charges on the top of their periodic table above the appropriate columns. Just remember the reason why you wrote that up there. Those charges are not numbers of electrons and protons. They're just the difference between the electrons and protons. So one more time. Take away one or more electrons for a cation. Add one or more electrons for an anion.